Greetings, we are Group O and this is our presentation on the given digital forensics assignment. Before diving into the core objectives of this assignment, there is a key term we must understand. What is digital forensics? As defined by the NIST CSRC, digital forensics is the application of science to the identification, collection, examination, and analysis of data while preserving the integrity of the information and maintaining a strict chain of custody for the data. With this in mind, we can turn our attention to the first objective, which states, before and after the acquisition of a forensic image, hashes are taken. Do you agree with this practice? Explain. A forensic image is an exact bit-for-bit copy of some physical storage medium, including folders, subfolders, files, free unallocated spaces found on the device, and even deleted and residual files hidden within the device. From this, we can understand how forensic imaging plays a key role in the digital forensics field. But how does hashing come into play with all of this? Hashes are simply strings of data that have been operated on through some algorithm and mapped to a fixed length of characters with the aim of providing security. A hashed piece of data cannot be unhashed and can only be retrieved or verified by rehashing the original string used. With forensic imaging, the goal is to create a bit-for-bit duplication of a storage medium, but there may be cases where this process can be interrupted by malicious or unintentional means and cause harm to the data integrity. Hashing the data before and after a forensic image solves this by creating subsequent hash values for the image that can be compared to each other, the before hash and the after hash, to validate the integrity of the data. Being that the same data is being hashed using the same algorithm, the hash values will always result in the same value. This unique digital fingerprint of sorts provides a safe and secure level of protection over a forensic image, and thus a well-implemented practice.
So, you want to know about the difference between digital forensic software and generic recovery software. But before we do all that, let me give a brief explanation on each type of software. Firstly, digital forensic tools are software used to aid in the discovery of computer evidence with the intention of it being used in the court of law. There are various digital forensic tools, such as the Sleuth Kit, which is used for disk analysis, FTK Imager, used for creating images of disk, and is also a free product by the way. Volatility, which like its namesake suggests, is used for analysis of volatile memory of the computer, along with many other tools that are suited for investigating some aspect of a computer in order to find evidence. Meanwhile, on the other side of the spectrum, the ordinary software recovery tools are available for general use. For example, when someone accidentally loses some important documents belonging to them, they may use data recovery tools in an attempt to reclaim their lost data. Generic software recovery tools are also much simpler to use as compared to DF tools, DF meaning digital forensics, as they do not contain as many features. Some examples of data recovery tools may be Recuva, which is used for recovering lost data, DiskDrill, SoftPerfect file recovery, and a litany of other software tools. So, to reiterate, the main difference between digital forensics and ordinary software tools is that the reason that the data is being recovered for. Digital forensic tools are used for criminal investigations that involve the use of computer systems, while ordinary software tools are for general use for the population.
Deleting a file may be one of the simplest ways to go about destroying evidence. Luckily enough, it can also be the simplest one to recover evidence from. When recovering evidence, if the file was simply deleted, it can easily be found in the recycling bin. However, in the case the file was permanently deleted, it may be slightly more difficult than searching through the recycling bin to find evidence. Not all hope is lost though, since when files are deleted, they are not actually deleted. To elaborate, when a file is permanently deleted by Windows or other operating systems, the file system record that holds the information to the address of where the data is located is marked as deleted. The disk space where the file is located is then labeled as available but not overwritten by other data right away. This is where digital forensics tools come in, as they are capable of combing through the disk to find these not so deleted pieces of data, as long as they have not been overwritten. The only problem with this method of recovery is the time taken between file removal and file recovery. If action is not taken within a certain period of time, then the file may be overwritten and the evidence lost.
If you wanted to find out if Charis was the one who accessed certain files on our computer, one way you can do this is by using Windows Event Viewer. Windows Event Viewer is a software found in Windows systems and was created by Microsoft. It can be used to monitor activities on your system and can be used to get information about your hardware and software. To use Event Viewer, first you need to enable auditing permissions in your settings. Then you need to configure the settings to be able to audit all the individual files or folders that you want to monitor. After you enable the permissions for that, you can then use Event Viewer to view logs. Some of the information you can view are system username, system domain name, the type of object, the name of the object, and the process name. Event Viewer can show you errors, warnings, information, success audits, and failure audits. One disadvantage though with using Windows Event Viewer is that it is tedious to set up everything and to go through everything manually, and you'd have to have Event Viewer set up in advance. That is it for the brief overview of Windows Event Viewer.
Is question 5. So we are asked to choose one open source DF tool capable of recovering deleted files from Charis's computer. And we also need to justify the selection of this tool and give a brief overview using screenshots or a live demonstration of how the tool is used. So the digital forensic tool selected is the Sleuthkit Selection Autopsy. After reviewing the proposed situation in the assignment background and comparing it to the digital forensic tools available today, we will need to identify a tool that meets a certain set of criteria. So the chosen digital forensic tool for this task is the Sleuthkit Collection Autopsy software. The justification for the tool selected are as follows. So the first one is it is open source and free. The autopsy also provides a GUI, graphical user interface, for users to interact with, which may aid the system administrator in functionality. It also has the capacity to produce quality reports that can be used for legal procedures. Most importantly, it comes equipped with the default and necessary tools to carry out a full and in-depth digital forensic examination on any hard drive or smartphone device, which means it has the capabilities to search and find deleted data from the device. In this case, it will be Charis's company laptop. So we have email, call logs, SMS, contacts, etc., analysis, and data extraction. So we also have file typing, is one of the justifications, and thumbnail displays for quick view. So now for a brief overview of the use of the tool. So this is when you open an autopsy. Here you see a snapshot of the opening. This is when you're setting up the project name and storage location. You see the case name and the directory where you want to store it, and some basic other information. Here's where you add some additional information in case you're dealing with a legal case. So you need to add these things. Here's where you set in the data type, the type of data source for the project. Here's where you set in the data source for the project. You need to set that. Next step is, as the thing said, adding modules and functions that the user needs for the project. So you configure ingest module, that's what they need. Add in the modules and function that the user might need. main screen with the compiled data for viewing. So this is what the main screen looks like. And at the end of it all, you can generate a report for the project.
And with this, we come to the end of our presentation.